Okay, boys and girls, this is what you call a smoking gun. Okay? Here is the test setup. I have a Tektronix 465 dual trace oscilloscope. Channel 1 is set to 50 volts per division. Channel 2 is set to 0.2 volts per division. My sweep rate is 2 milliseconds per division so that we can look at the entire sinusoidal waveform of 60 hertz coming into the house. Channel 1 is connected directly to one side of the 120 volt AC split phase. Channel 2 is connected to the other side of the 120 volt AC split phase through this capacitive resistance decade box. Channel 2 passes through a 0.001 microfarad capacitor, or 1000 picofarads, and is shunted by 1000 ohms. So what we are looking at in channel 2 is the voltage that appears across the 1000 ohms from the series 0.001 microfarad capacitor connected to the other side of the 120 volt split phase. So my channel 1, you see the scope probe is directly on one side of the split phase. Channel 2 is on the other side of the split phase, and they both look identical. And here is what we've got. Turning up the intensity. You can very plainly see RF interference, spike RF interference. Now I'm going to turn the exposure rate down a little bit here. Controls. And with the exposure down, you can see very clearly, A, that is not a sinusoidal waveform, and B, there is definitely some RF interference that is tied precisely to the line frequency. Now the next thing I want you to see is I'm going to go to 1 millisecond per division. Now I'm going to go to half a millisecond per division, and I'm going to turn the intensity down a little bit so that you can see on this waveform. All right, this is one of the major spikes right here. Notice it coincides directly with a waveform deformation on the 120 volt 60 cycle coming into the house. It takes a lot of juice to cause that kind of deformation on the sinusoidal waveform. Okay, this is 200 amp service coming into my house. Here is a wider, not quite as tall RF spike, and it corresponds to a wider, not quite as deep deformation on the sinusoidal waveform. And there you have the smoking gun. I'll turn off channel 1. We'll look just at channel 2. Crank up the intensity, and you get a really good look at those spikes. Aren't they pretty? Aren't they pretty? So there's definitely some arcing going on somewhere. My concern is that that arcing might be underground downstream from the weatherhead where Eversource has their utility feed coming to my house. If that's the case, then unfortunately that's on me, because that's the customer-owned side of the utility service. I will not know that until Eversource comes and disconnects my house from the street. I have disconnected my service by yanking the main power fuse on the panel here, as well as turning off the main breaker to the radiators. All right, this is my electric heat panel, and then this fuse panel feeds the rest of the house. So by turning off those two main breakers, I completely disconnect the house from the service. With the house completely disconnected from the service, I still get the noise, but I'm still downstream from where the arcing might actually be taking place, being underground between my house and the utility pole. So I'm a little concerned about that, but I will be calling Eversource and giving them this information, showing them this video, and ask them to come out and shut the service off to my house to see if this goes away. I hope it doesn't, because that would mean that whatever is arcing and causing this this interference is on their side of the utility service. But if it's not, then obviously I'm going to have to take care of it myself. That's all for now.